In this section, we will work with Hyperledger Fabric and Composer. We will start by building a Hyperledger Fabric network, and then establish a connection to it from Hyperledger Composer. We will also glance at how to configure our network. Finally, we will play around a bit with the aptly named Hyperledger Composer Playground. In this video, we will set up our first Hyperledger Fabric network. We will learn how to use the Fabric development server scripts that we downloaded in section 1, how to start the relevant Fabric containers, and how to create and join a channel. As usual, we connect to our virtual machine. As you remember, in section 1, we downloaded the Fabric development servers. We will see what scripts are in there and go through them step by step, so we can understand what is happening at each stage. Let's look at the download Fabric script we used in the first section. As you can see, it references the loader script in the same folder. Let's see what the loader script contains. The first thing to notice is a reference to a variable called HL_Fabric version. This is assumed to be by default the Fabric 1.1 version. There is also a Fabric start timeout, which we will leave as is. 15 seconds is more than enough. The Fabric version variable determines which script folder is used. Let's create a Zesh environment configuration file. Here we will save our HL_Fabric version variable, so that it always loads when we open a new terminal screen. Again, we will use Fabric 1.1. And we save the file. And we source it to load the environmental variable in this terminal screen. Let's display the environmental variable using echo. I'll type the first characters and create a Zesh environment. Let's enter the Fabric scripts directory. The folders here correspond to versions 1 and 1.0. We enter the HLF v11 folder. Here are the actual scripts that are referenced in the Fabric dev servers folder. Let's again look into the download Fabric script. The key commands here start with docker pull and download the relevant Docker images. These correspond to the peer, certificate authority, chain code environment, orderer, and the CouchDB store. Since we downloaded them in section 1, we can run Docker images to display them. Let us now look at the start Fabric script. There are several functions here. One to display help, and another to parse arguments provided to the script. The first key command detects the architecture of our system and saves it to the Arch environmental variable. Let's create a new Biobo screen by pressing F2. We run exactly the same command to get the architecture. As we can see, we have an x86 64-bit architecture. And let's shift Biobo screen by pressing F3. The next useful command is to get the current directory where the script is running. In our case, since we're not running inside the script, we can just run the pwd command. Again, we can display the result. The next command selects the appropriate Docker Compose YAML and assigns it to a variable called Dockerfile. We will not be using the Fabric development mode, so we will select the plain Docker Compose YAML. Again, we can verify we got the correct file. The key commands in this file are the Docker Compose commands, which use the template specified in dockercompose.yaml to launch a set of containers running our Fabric images. Let's run the first command, which stops the set of images corresponding to a Docker Compose template. In my case, I had a Fabric cluster running, so this command stops it. Let's use the second command to actually start the cluster again. This launches the peer, its CouchDB database, the orderer, and the certificate authority. We can run docker ps to display the running Docker containers. And we can use the docker logs command to look at the logs of each container in turn. Let's start with the orderer. The orderer has started without any errors and is beginning to serve requests. Let us look at the logs inside the peer. We see a similar picture to the orderer, with log messages but no errors inside. The CouchDB database that holds the peers blockchain has a different log format and has also successfully started. The next key command uses docker exec to execute a command on the peer, using its peer command line interface to create a channel called Composer channel, which will be used by Hyperledger Composer. This command also requires us to specify an orderer node with which to communicate, as well as a channel configuration transaction, which we will cover in more detail later. Running the command will display some logs from the peer showing that we successfully created a channel. Namely, we received block 0 for this channel. Now we can run a second command which actually joins the peer to the channel. We will reference some cryptographic material by passing it as an environmental variable into docker exec. We will discuss the creation of this cryptographic material in more detail later. And we will also specify a block file, which was retrieved when we created the channel. The logs show that the peers successfully submitted their proposal to join the channel. In this video, we set up the relevant environmental variables to specify the Fabric version we want to use. We cleaned up any previous Fabric deployments we had. We then started the Fabric containers and checked that they are running by examining their logs. And finally, we created a new Fabric channel and joined our peer to it.